Thanks very much. It's my great pleasure today to talk about a collaborative project between the ANU UWA, AIMS WA, and the Department of Environment Conservation WA. Talking today basically about these seaweed habitats that we're finding in Ningaloo, and to some extent contrasting them with our understanding of seaweed habitats on reefs on the east coast. So the perception of seaweeds in marine ecosystems can vary, and a couple of extremes I've presented here is if you see seaweed on your coral reef, you may take it as a negative sign of degradation, but in the literature, a lot of other people take seaweeds as a facilitator and a good sign, something that bolsters biodiversity in benthic ecosystems. And I guess from our point of view, coral reef ecologist point of view, that depends on their proximity and threat to hard corals. In particular, it's their location. Do the seaweeds that you're finding, the large fleshy seaweeds, occur alongside these hard corals, and are they overshadowing them? And also the timing. It depends on whether these things are seasonally coming and going, which we often see in healthy systems, or whether they persist over top and smother the corals. And what this means is we really need to understand the factors that will drive the location, size, and timing of large stands of fleshy seaweeds on coral reefs. Now, we do have some understanding, and we can take it from literature both in temperate rocky reefs as well as tropical coral reefs. This is a temperate example, and one of the main things we see driving algal biomass in some of these reefs is climatic conditions. Here we've got sunlight and surface temperature, and as those two parameters pick up, we see an increase in kelp biomass, and then another climatic factor, wave height, when that starts to pick up in the same season, we see a breakage and reduction in kelp biomass on those reefs. We also know that herbivory and nutrients can play a strong role in shaping algal biomass on reefs. This experiment here by McClanahan and others was looking at both the addition of nutrients and the removal or exclusion of herbivory and the variable effects. In some cases, the fleshy browns benefited most by being protected from herbivory but didn't really benefit from the addition of nutrients. So it's not always straightforward, but all of these factors do have an influence. And obviously habitat availability. Algae does need a hard substratum to attach to. So we can put some of these together and we can start thinking about models of seaweed biomass, timing, persistence, and their location. But I guess the one point I wanted to make, because I'm talking about Ningaloo today, is that a lot of this understanding seems to be centred on other locations. And when we're talking about Australia, we have a very East Coast skewed perspective on some of this stuff. This is a paper by Becky Fisher pointing out how many papers are published relative to the reef area in a given location, coral reef location around the world. And just focusing on Australia, we can see that the Great Barrier Reef has a much higher proportion of papers than you expect based on the reef area than somewhere like the West Coast and Ningaloo. So, and here we've got a figure by Tyrone Ridgway from AIMS pointing out how many Web of Science hits they were getting for publications based at the GBR relative to the very tiny proportion on Ningaloo. So I'm wondering, do we have a bit of a skewed perspective about our understanding of seaweeds in coral reef ecosystems and whether we could learn something new from Ningaloo? Ningaloo is an interesting system. Technically it is a fringing reef. It's the largest in Australia. It's also the largest in western landmass. It's around 300 kilometres long. It's a key tourist destination. Around 2,000 visitors per year come to Ningaloo, particularly in the season of April to October when the whale sharks are migrating through. It's also a huge money spinner. Roughly half of the tourist income that involves natural resources in WA involves Ningaloo, and roughly a quarter of all Australian international visitors come to Ningaloo. From an environmental perspective, it's interesting because it straddles the Tropic of Capricorn, so it has high variation in things like water temperature. It's also a very high wave energy environment. There's not much out in the Indian Ocean in the way to stop the wave action, so we get very large oceanic swells impinging on this coast for most of the year. And the other thing that's interesting about it from an algae point of view is it's very arid. There's low rainfall, there's low terrigenous inputs, and combined with the fact that there's a very low population density in this reef system, we have relatively low nutrient input from the land. Most of it is upwelling that's occurring from the sea. So Ningaloo, relative to the Great Barrier Reef, is a very different system. And so what we wanted to do is characterise the seaweed habitats that you find within the Ningaloo landscape. And we did this across a couple of scales. We had two locations, one in the north in Tandabidi and one in the mid in Coral Bay. We chose these sites in particular because of the oceanography of this system. In this northern part of Ningaloo, we predominantly see influence from the Lewin Current, and in this more southern part of Ningaloo, it's influenced by the Ningaloo countercurrent, so that's for the reason for the choice. And at the local scale, we took 3 sites at each of these locations, and we did harvest surveys within quarter-metre squared quadrats of every algal individual we could find in algal-dominated habitats, and I'll show you where they are in a second. We did 6 of those per site, and at the same time we put out loggers to monitor light, temperature and wave height continuously, and we've got them continuously running now. It's been going 18 months, it's going to continue to go for the foreseeable future. We then wanted to scale that up to the landscape, and so we're using remote sensing techniques, in particular multispectral satellite imagery, WorldView 2 satellite imagery to be exact. And we're using this in combination with what we call ground control spots or ground truthing to actually work out the spatial extent of these habitats along the full length of Ningaloo is the ultimate goal. And we've repeated all these seasonally, roughly every 3 months. We're also doing a range of other things with the algae themselves. We're looking at their demography, the growth rates and tissue analysis, the development of reproductive structures, their recruitment through recruitment tiles. And then on top of that, we're also looking at things that might be driving the seasonality. So we're also interested in their biomechanics, things that will determine whether they persist on the reef or get broken off by physical processes, and building shear stress models to do that. So that's the methodology, and I'm going to present you some of the work we've done today. As I said, it's an ongoing project and one we're continually finding new things with, and I want to just basically introduce you to the system. So what do they look like? Well, the seaweed meadows that we find are typically in the lagoonal habitat of Ningaloo. Yes, it's a fringing reef, and as Sean mentioned, it does have extensive lagoonal sections, particularly in the north. And you can find these relatively discrete meadows that will appear in certain patches of that lagoon. And they can look very different from one location to the next or from one season to the next. And this is just 2 typical photos from the one site between sort of late winter and late summer. They are extensive, and the rough estimates we've done so far, we're still processing the satellite imagery, but the rough estimates we've done so far suggest that this, as a habitat by area, is comparable or maybe exceeds the coral-dominated habitat found on Ningaloo. So it's an extensive resource. And in most cases, we find them spread relatively evenly throughout the lagoon. So on this particular image, we've taken a whole heap of spots where we've stuck our face over the boat, an estimated % cover of algae, and then we've used that to code these multispectral images that have the capacity to penetrate down to 3 or 4 metres depth where these algal beds occur. And we're finding extensive seaweed meadows all throughout the lagoon. This is just one small section near Coral Bay. So it's an extensive habitat. But as I say, it's dynamic. It doesn't just look the same and stay in the same places. Not only are we finding this kind of variation between a large amount of weed and a small amount of weed between seasons, but often between years we can see enormous changes in the shape and size. For instance, this is a set of equipment that we'd set in one site in northern Tanabiddi, and we went back the same time next year after 3 cyclones had passed through, and we find that it's covered in 2 inches of sand. So these habitats do contract and they shift around. To put some numbers to that and actually examine what's going on, the typical pattern we see in these seaweed meadows is they do persist from year to year, but that they change dramatically in terms of their biomass and the complexity of what's there. This is a photo series from sort of late winter into spring and then on to late summer of what you'll find in one site of one of these seaweed meadows in Ningaloo. And along the bottom here are some numerical estimates to characterise that. On the left, we see a general drop in species richness as we go from the winter months where there's relatively low cover, there'll be lots of species, and that drops away into the summer. And we believe that is because the biomass of sargassum species in particular will start to pick up as we come into summer, and in particular their canopy height will increase to a relatively large size, several feet in some cases and in several metres in others. So this is a habitat for fish and other species, is quite a changeable one in terms of the seasons. And what we're interested in particular are what are the triggers that lead to these changes. Now we believe very strongly, based on past literature, that light and temperature are triggers for the initial growth of these seaweed habitats. But what we're interested in now as well is what happens at the end of that cycle. So we've come to late summer, we've got a seaweed bed here,
and we're wondering what actually triggers it from going to an extensive and complex seaweed meadow that we see here to one that's been dislodged and back to the stipe phase that we see in winter. And one of the things we think is a key trigger is wave energy, because in late February, early March, as far as we can tell so far with a few years of data, the trade winds, the southwest trade winds, pick up, and we see an increase in the amount of wave energy that starts impinging in the lagoonal habitats. And this particular plot is to give you an indication of what the wave height spectrum looks like between the outer reef crest and across the back reef and into the lagoon in Ningaloo habitats, and the attendant flow velocities that are created by that wave action. And the flow velocities we are seeing do create shear forces that will remove the sargassum species that we're finding in these meadows once they reach a certain threshold, which we believe in this case for this particular set of species from Tanabiddi is around 3 metres per second. When those flows start impinging on the seaweed beds, they remove the macroalgae. Now the interesting thing is that this is a climatic trigger, so it's a broad scale mechanism. It's not just one or two beds that may go, it may be an entire section of reef, so it's a landscape-wide process. And this is interesting, as Sean mentioned, because it's not just the seaweeds we're looking at here. As I said in the beginning of the talk, they are also considered facilitators. There are many, many other species that live within this seaweed habitat, which is of comparable area to coral-dominated habitats on Ningaloo, and I would argue of comparable complexity from a habitat perspective. We've found over 40 species of gastropod. There's been in total now 75 species of seaweed, and we're still working through the myriad of other invertebrates, but the work that Sean and his colleagues have done on the fish has also shown that it's an extensive habitat for, yes, seaweed-dependent species, species that we only find in the weed beds, some of which are commercially important and functionally important, but a whole range of other species that we normally consider as coral-dominated habitat species are also using the seaweed beds for shelter, presumably. Now, if the timing of persistence in these seaweed beds, when they're broken off the seabed, is discordant to when these fish are recruiting to these habitats, we might expect a recruitment failure to occur in some of these species. So the timing and persistence of seaweeds in this case is not only a question of whether we may or may not have a degradation of coral-dominated habitats in something like a coral algal phase shift, but on the other side of the coin we could see a situation where we have a collapse or lack of support for coral reef biodiversity because of a lack of persistence in seaweeds. And so I guess the main conclusions I'd like to make today is that seaweeds do have an important role to play in maintaining coral reef biodiversity and of course productivity, something we haven't looked at yet, that they are a dynamic habitat, and that because these timing and persistence of this habitat is driven by climatic triggers, it often leads to landscape-wide changes in their availability. And since they are often facilitating many other species, such as the recruitment of functionally and commercially important species, this can have flow-on effects to many other species as well as to the function of Ningaloo reef ecosystem. And I guess the last point I'd make, given that this is the coast-to-coast symposium, is that Ningaloo's near reef meadows really provide us with a contrasting understanding of where seaweed-dominated habitats can occur on coral reefs and their role versus something we would see on the Great Barrier Reef, where the seaweeds typically arise embedded amongst coral-dominated habitats and then subside again seasonally. Now, thanks to many people for funding, field assistance and helpful discussion and images. Thank you.